Hello, and welcome to Lab 2, Part C, Oceanic Hotspots. For Part C of your lab section, we will be using Google Earth. To begin, turn on Layer Part C and turn off Layer Part B. Then double-click Layer Part B and Google Earth will zoom to the Hawaiian Island Emperor Seamount chain located in the Pacific Ocean. Next, adjust your view so that it's similar to what's seen here in the video. To do so, experiment with the arrows and scroll bar located in the top right corner. Also, you may need to readjust north based on your view by either typing R or by clicking the little circled N near the top right corner. The Hawaiian Island Emperor Seamount chain is the most famous example of a trace of seamounts and volcanic islands created by an ocean hotspot. The Hawaiian Ridge, which includes the Hawaiian Islands, and the Emperor chain together form the Emperor Hawaiian chain. Recall that volcanic activity is only occurring above a stationary hotspot currently located below the Big Island of Hawaii. The other islands and seamounts were once located above the hotspot, but have since moved away by the movement of the Pacific Plate. Thus, their position is directly related to the direction and speed of the Pacific Plate. Since we know the ages of the various islands and seamounts, we can determine the motion of the Pacific Plate. For this lab section, you will answer various lab questions about the Emperor Hawaiian chain. For example, how does the age of the ocean crust change along the Emperor Hawaiian chain? Here you will use the data provided in Google Earth to answer your lab question. Or, if the Emperor Hawaiian chain is attributed to a stationary hotspot, then predict the direction of motion of the Pacific Plate, for example, southwest or east, for example, for the following times. From 0 to 43 million years ago for the Hawaiian Ridge, and from 43 to 60 million years ago for the Emperor chain. Make sure to include in your answer what happened to the direction of the Pacific Plate approximately 43 million years ago. Many of these seamounts were once islands and sunk beneath the ocean surface after they were cut off from the hotspot magma source, and subsequently began to cool, contract, and erode away. Based on their ages and relative sizes, which island would you predict to sink beneath the ocean surface first? Kauai, Niihau, or Hawaii? To answer this question, you'll need to consider the ongoing effects of erosion and how it relates to the island's size over time. Finally, Loihi is a small undersea volcano located to the south-southeast of the island of Hawaii. If the hotspot is currently located underneath the Big Island of Hawaii, then would you predict the average radiometric age of Loihi rocks to be younger or older than Hawaii? Also, what might Loihi evolve to over geologic time? Perhaps it's turning into the next Hawaiian island? Next, you will calculate the average plate motion, or speed in centimeters per year, for the Emperor chain. To do so, use the formula rate equals distance divided by time. For distance, use the ruler tool to measure the distance from the youngest to the oldest seamount. For time, calculate the time to form the Emperor chain by subtracting oldest from youngest. Then, before you insert your distance and time data into your formula to calculate the rate, make sure that you convert the units to centimeters per year. And finally, repeat this process to calculate the average plate motion, or rate, for the Hawaiian Ridge, using the same method used for the Emperor chain. This concludes Lab 2, Part C, Oceanic Hotspots. After completing Part C in your lab assignment, Watch video 5, part D, fracture zones versus transform faults. Please address your questions to your lab TA.